This is Mr. Martin. These are the video notes for section 7.4. We're going to be talking about regular polygons. So let's start out with a definition. So a regular polygon if a polygon is regular, then it is equiangular and equilateral. So all its angles have to be the same and all its sides have to be the same. So a rectangle is not equiangular even though it has all equal angles because its sides are unequal. And a rhombus is not regular because even though its sides are all the same, its angles are not. Alright, so we're going to be talking about polygons where the sides and the angles are all congruent. Alright, so let's look at a theorem. So the measure of each exterior angle in a regular polygon. Okay, so we're talking about the measure of an exterior angle, which we call E. Now, we know that all the angles add up to 360 for any polygon. We talked about that in section 7.3. So if we know that all the exterior angles happen to be the same, and we want to find out what one of them is, we just take 360 and divide by how many there are. And this is going to be a really useful formula for us. All the examples that we look at today, there are other ways to do them, but personally I think the easiest way to do them is by using this exterior angle theorem, and we'll talk about that in a minute. Alright, one more thing before we look at some examples. Remember that an interior and exterior angle of a polygon are supplementary. So a formula that I will use quite often again is an interior angle plus the exterior angle is equal to 180. Okay, so keep this in mind, and I'm going to use this quite a bit when we do the examples. Alright, so example number 1. Find the measure of each exterior angle of a regular octagon. Alright, so I've got our formula. E is equal to 360 divided by n. I know that octagon has 8 sides. 360 divided by 8, 45 degrees. So just to make sure that we're clear on what we're looking at here, here's my octagon. Just pretend that it's regular. I'm not going to draw in all the angle symbols, but we'll pretend it's regular. And I'm going to draw one exterior angle. This angle here is going to be 45 degrees. Alright, next example. Again, feel free to pause the video anytime if I'm going a little bit too quickly. I want to make sure I get all the examples in under 15 minutes. Alright, so example 2. Find the measure of each angle of a regular dodecagon. So Again, there's a couple different ways you could do this. We can find the sum of all the angles using our formula from the last section. S sub I is equal to n minus 2 times 180. And once I find the sum, I could divide by 12. Or I can find the measure of an exterior angle first by doing 360 divided by n. So that would be 360. Dodecagon has 12 sides. So I know that each exterior angle is going to be 30 degrees. Then, since I know that the interior angle plus the exterior angle is equal to 180, I can find the interior angle. So I plus 30, I just found the exterior angle, is equal to 180, which means that I is going to be 150. Okay? Again, I really don't care how you do it. But I prefer to use the exterior angle theorem just because it's so much simpler. All right, example 3. And again, if you want to pause the video after I get the problem written down and try it on your own, feel free to do that as well. So, how many sides does a polygon have if each exterior angle is 18 degrees? Alright, so we're talking about the exterior angle. Again, I know that E is equal to 360 divided by n, and now we're trying to find n, and I know what E is. So E is 18 degrees, so 18 degrees is equal to 360 divided by n. I'm going to put this over 1, so I have a proportion here, and then I'm just going to cross multiply. So I have 18n is equal to 360, divide both sides by 18, and I get n is equal to 20 sides. Okay, now make sure you pay careful attention to the problem, because if I said what is the name of the polygon if each exterior angle is 18, we still have to find n, but once you get here, then you would write that the polygon is an icosahedron. Alright, next example. As always, if you have questions, make sure you write them down in your notes here so that you can ask me when you see me in class. Example 4. If each angle of a polygon is 108 degrees, what is the name of the polygon? Alright, so if it says each angle, if it doesn't specify interior or exterior, then it's implied that it's interior. So really what I know is that I is equal to 100 or 108 degrees. So if I know what I is, I can find E. I know that E is going to be 180 minus I, because I know that the interior and exterior are supplementary, so that's 180 minus 108. So that gives me 72 degrees. So I know that the exterior angle is 72, and I know that the exterior angle is 360 divided by n. So I can substitute in for E. So I've got 72 degrees is equal to 360 divided by n. Put this over 1. I'm going to cross multiply. 72n is equal to 360. Divide both sides by n. I get n is equal to 5, which means the polygon is an equiangular pentagon. Okay, so we know that the exterior angle is 72, but we really don't have any information about the sides. But we do know that since each of the interior angles is 108, each of the exterior angles have to be the same, so we can use this formula. We just don't know that it's regular, but we do know that it's equiangular. Alright, last example. Let's insert some space here. So example 5. Find the number of sides of a regular polygon if each angle measures 12 degrees. Okay, so again, this is my I. So this tells me that I is equal to 12 degrees. Again, I like to work with E, so I know that I plus E is 180. An interior angle plus an exterior angle is 180. So 12 plus E equals 180, which means that the exterior angles all measure sorry, so I've got 168 degrees. That's each, something's not right here. Each X, I'm sorry, if each, this should be exterior. Sorry about that. Alright, so all of this is wrong. I just missed that word exterior in my notes here. So this tells us that E is equal to 12, so that makes it even easier. So I know that E is equal to 360 divided by N. It wouldn't make sense for the interior angle to be 12 degrees anyway. So I know that 12 is equal to 360 divided by N. Put that over 1, cross multiply. I get 12N is equal to 360 divided by 12, and I get N is equal to 30 sides. Okay, sorry about that mistake. It's the exterior angle that's given, and then we have 30 sides. So if you have any questions, make sure you write those down and ask me in class. And if you want to start working through the problems for this section, feel free to do that. And we'll see you next time.